Vacuum exposure. Perhaps the most terrifying and immediate way to die in space is through vacuum exposure. When a person is exposed to the vacuum of space without a spacesuit, the results are catastrophic. Contrary to Hollywood myths, the body doesn't explode. Instead, the absence of atmospheric pressure causes bodily fluids, like saliva and blood plasma, to boil at body temperature, a condition called embolism. This leads to severe swelling, though the skin holds everything together. Consciousness is lost within 10 to 15 seconds due to hypoxia, as the body is deprived of oxygen. If air is in the lungs when the vacuum hits, it can rupture the lungs due to pressure imbalance. Death follows within 2 minutes, often from asphyxiation, circulatory failure, or embolism. In real life, a NASA technician in 1966 experienced accidental vacuum exposure and described the feeling as the air being sucked out of his lungs before losing consciousness. But he survived because he was repressurized quickly. Hypoxia. Hypoxia, or lack of oxygen, is another silent but deadly way to die in space. When oxygen levels drop below what the body needs, brain function deteriorates quickly. In a spacecraft or suit malfunction, even a small drop in oxygen concentration can be lethal. Within seconds, the brain becomes starved of oxygen, causing dizziness, confusion, blackouts, and eventually death. What makes hypoxia particularly dangerous in space is that it can happen without immediate pain or awareness. Astronauts may smile or feel euphoric right before passing out. In confined spacecraft environments, especially if there's a leak or oxygen system failure, hypoxia becomes a ticking time bomb. It's a gentle killer, until it's not. Radiation exposure space is flooded with ionizing radiation, including cosmic rays and solar particle events. Earth's atmosphere and magnetic field protect us on the surface, but in space, those shields don't exist. Prolonged exposure damages DNA, increases cancer risk, and affects the nervous system. A massive solar flare could deliver a lethal dose in hours. For astronauts on the International Space Station, radiation is a concern, but it's managed with shielding and time limits. However, on long-duration missions to Mars or deep space, radiation could kill through acute radiation syndrome, nausea, vomiting, internal bleeding, and organ failure within days. The worst-case scenario is a solar storm hitting a spacecraft with no protection. In that case, death could come painfully fast. Rapid decompression. When a spacecraft or suit suddenly loses pressure, the effects are both violent and deadly. Rapid decompression forces gases in the body, like nitrogen and oxygen, to expand, potentially rupturing tissues. The lungs can be torn apart if you don't exhale instantly. Blood vessels can burst, and the eardrums may rupture. Additionally, as the pressure drops, embolism causes fluids to vaporize, leading to swelling, hypoxia, and unconsciousness. Decompression incidents can also lead to flash freezing if external temperatures are low. In 1971, the Soviet Soyuz 11 mission suffered a cabin depressurization on reentry. All 3 cosmonauts died silently, with autopsies confirming their lungs had hemorrhaged due to pressure loss. Freezing, it's commonly believed you'd freeze instantly in space, but the truth is a bit more nuanced. Space itself doesn't have a temperature in the traditional sense because it lacks air or matter to conduct heat. Your body would lose heat slowly through radiation rather than conduction or convection. However, if you were exposed to space in the shadow of a planet or spacecraft where temperatures can dip below minus 250 degrees Fahrenheit or minus 157 degrees Celsius, parts of your body could freeze over time. Blood wouldn't freeze instantly because internal heat would delay it, but extremities and skin might suffer frostbite quickly. If you were already dead or unconscious, your corpse would freeze solid after many hours, turning into a space mummy. It's a slow, cruel process rather than an instant one. Overheating, solar exposure. On the flip side, being exposed to direct sunlight in space can cause overheating. Without an atmosphere to filter solar radiation, your body could be bombarded with intense heat. Temperatures in direct sunlight can exceed 250 degrees Fahrenheit, 121 degrees Celsius. A spacesuit typically regulates temperature, but without one, skin can burn rapidly. While the vacuum prevents traditional heat transfer, sunlight is still absorbed via radiation, cooking your exposed body parts. The worst part is that while your front side could burn, your backside might freeze, creating an extreme temperature differential that can cause thermal shock, disorientation, and damage to vital organs before eventual death from heat stroke or combined stress failure. Micrometeoroid impacts space is not empty. It's full of tiny high-speed particles called micrometeoroids. These particles travel at tens of thousands of kilometers per hour, and even a small one can pierce spacecraft hulls or spacesuits like bullets. A direct impact to a spacesuit could cause immediate suit failure, rapid depressurization, or fatal injury. Inside spacecraft, a breach can lead to cascading equipment failure or even explosive decompression. In 1983, the Space Shuttle Challenger was hit by a tiny paint fleck that caused a small but notable crack in its windshield. Luckily, no crew was harmed, but the danger is real. In deep space, with no atmosphere to slow them down, these tiny assassins are a constant threat. Spacecraft reentry failure. Returning to Earth is just as dangerous as leaving it. If a spacecraft fails during reentry, the consequences are horrifying. The vehicle reenters Earth's atmosphere at speeds over 17,000 miles per hour, 27,000 kilometers per hour, generating intense heat, up to 3,000 degrees Fahrenheit, 1,650 degrees Celsius. Heat shields are essential for protection. If they fail, the craft disintegrates mid-air, and death is instantaneous. This was tragically seen in 2003 with the Columbia disaster. The shuttle disintegrated over Texas due to damage to its wing, killing all 7 astronauts. The G-forces, heat, and structural breakup ensured there was no survival chance. A minor oversight during launch had triggered one of space's most tragic death types, mechanical or equipment failure. Technology in space must be flawless. Even the smallest mechanical failure can lead to death. This can include oxygen system malfunctions, broken life support systems, failed thrusters, or electrical shorts. Any of these can cause fires, suffocation, loss of trajectory, or power blackouts. In 1971, cosmonauts Dobrovolsky, Volkov, and Patsayev aboard Soyuz 11 died due to a cabin valve opening prematurely, leading to depressurization. More recently, the fire aboard the Mir space station in 1997, caused by a malfunctioning oxygen generator, could have easily turned fatal. Astronauts managed to contain it, but it demonstrated how even one faulty component could result in space death. Being lost in space. One of the most psychologically terrifying ways to die in space is being accidentally set adrift. A malfunctioning tether, thruster misfire, or docking failure could send an astronaut floating into the void forever. With no way to return and no means of communication, the astronaut would be completely isolated. As the oxygen depletes, they'd remain conscious for a few minutes before passing out, then die of hypoxia. Their body would continue drifting for eternity, untouched by decay in a frozen, mummified state. It's a slow, hopeless death, where the real killer is loneliness and the sheer indifference of space. Starvation or dehydration. In the event of a failed mission, isolation, or loss of communication, astronauts could be stranded without supplies. Spacecraft carry limited food and water. Without resupply or recovery, crew members could face slow, painful deaths by starvation or dehydration. Dehydration would strike first, causing hallucinations, organ failure, and ultimately death within about 10 days. Starvation would take longer, but is equally brutal, weakening the body and mind over weeks. The psychological torment of knowing you're unreachable would intensify every moment. Although protocols are in place to prevent this, a catastrophic failure in deep space could still lead to this grim outcome. If you found this video fascinating, make sure to like, share, and subscribe for more mind-bending science content. Until next time, stay grounded.